And welcome to Victory Online Academy. In this session, we are going to discuss geometric sequence and series. Let's start with a real world example of a bank. So there is a bank which gives 7% per annum interest rate. Okay, and you deposit $100 in the beginning of the year. So after 1 year, you are expected to get 100 plus 7%. I've shown the calculation here. So 100 plus 7% on 100. So 100 multiply 1.07. This is the amount you will get at the beginning of the second year, right? So if you want to find out what you will get at the beginning of third year, so so this was the amount at the beginning of second year, plus you will get 7% on this. So 7% of this of 100 into 1.07, and when you simplify that, what you will get is 1.07 square multiply 100, that you will get at the beginning of the third year. Similarly, at the beginning of the fourth year, if you simplify, you will get 1.07 cube multiplied by 100. Now what you can observe here is that there is a pattern. The pattern is the pattern in the amount you will get at the beginning of each year. The pattern here is the the second the amount which you will get at the beginning of the second year is 1.07 times of the amount of the previous year. Similarly, uh, the the amount at the beginning of third year is 1.07 times of amount at the beginning of the second year. So if you want to find out, there is a pattern, as you can see here. See, 1.07 cube, here is 1.07 square, here is 1.07 power 1. So if you want to find out the amount you will get at the beginning of the fifth year, that will be 1.07 to the power 4 multiply 100, right? So the as you can see here, if it is 4, you are seeing 3. If you are seeing at the amount at the beginning of fifth year, you are seeing the power as 4. So if you want to find out amount at the beginning of 10th year, so it will become 1.07 power 9 multiply 100, right? Using the pattern. So amount at the beginning of the nth year will be 1.07 power n minus 1 multiply 100. Is that clear? So these kind of numbers follow geometric sequence, like 100, then 100, then 1.07 multiply 100, 1.07 square multiply 100. So as you can see, the if you divide the second term if you divide the second term by the first term, that is u2 divided by u1, you will get 1.07. Similarly, if you divide u3 to u2, the ratio of the two consecutive term, any two consecutive term you see take, and if you find out the ratio or the division of the next term by its previous term, you will always get a constant, right? that constant is that constant is called common ratio. So common ratio in terms of geometric sequence, and which is represented as r, right? So so let's generalize. If a is the first term and let's say r is the common ratio, then what is the next term? Next term is r multiply the previous term, right? So if first term is a, the next term will be ar, right? Then the next term u3 will be ar square, like 1.07 square r square multiply a, which is 100. So ar square. u4, the next fourth term will be ar cube, right? So we can write all the terms. Similarly, we can write down the nth term. Nth term is arn minus 1. This is the formula of nth term in geometric sequence, right? So the difference between geometric sequence and series is sequences are ordered list of numbers. Like if I write, let's say 2, 4, 8, 16, 32. If I write using comma, so it is called geometric sequence. Okay, geometric sequence. Why it is a geometric sequence? Because the ratio of any two consecutive term is always a same number, a common. The ratio of any two consecutive term you take, that will be 2. 4 divided by 2 is 2, 8 divided by 4 is 2. So it's geometric sequence. But if I write like 2 plus 4 plus 8 plus 16 plus 32, so that in the sum form, right? If I write in the sum form, like let's sum of the first 5 terms, so this is called geometric series. In addition form, if you write, that becomes geometric series. If you write an ordered list of numbers, that's geometric sequence, right? And this is the very important formula. What we got is un, nth term of geometric sequence is arn minus 1, means first term multiply common ratio and common ratio power n minus 1. So let's take an example. If it is 3, let's say 9, 27, like that, so it is a geometric sequence. How we know that it's a geometric sequence? Because the ratio of any two consecutive terms, like 9 divided by 3 is 3, 27 divided by 3 is also 3, right? 27 divided by 9, sorry, 27 divided by 9 is 3. So it is a geometric sequence, right? Because the ratio of any two consecutive term is same. It's a constant. So it's a geometric sequence. Now if you want to find out, the 10th term of this sequence, you can easily find out using this formula. So we know that un is arn minus 1, right? So here a is 3 and r is also 3. The common ratio is 3, right? So we want 10th term. So 3 multiply 3 to the power 10 minus 1, which will give you 3 multiply 3 to the power 9, which will give you 3 to the power 10. So this is the 10th term of the this geometric sequence. Now let's solve one question here. Find the value of x if each of the following are in geometric sequence. So if this is in geometric sequence, we need to find the value of x or values of x. So we will use the property of the geometric sequence that ratio of any two consecutive term is always constant. It means x divided by 3 has to be equal to 48 divided by x, right? It's very simple. So cross multiply and you will get x square is equal to 48 multiply 3. So use the calculator and find out 48 multiply 3 and then take the square root. So you will get square root of 144. That can be plus minus of square root of 144, that can be plus minus 12. So there are two values of x. Okay, now the second is part b. This was part a. Now part b you can solve similarly. X divided by 5 over 2 is equal to 1 over 2 divided by x. Again you need to do cross multiplication. So x square is 5 over 2 multiply 1 over 2. So x square is 5 over 4, and x is equal to plus minus square root of 5 over 2. So this is the value of x. So it's pretty simple question. You just need to use the common ratio will be the same. So we have used here and we solved it, right? Let's move to geometric series. Geometric series. So geometric series is like sum of all the terms. So let's find out the sum of n terms of geometric series. So Sn, it means the sum of n terms, that is a plus ar plus this is the second term, this is third term, this is fourth term. Similarly, this will be n minus 1th term and this is the nth term, right? Now to find out the uh, uh, sum of n terms of the metric series, it's very easy to derive. You multiply with r, the common ratio, rsn. You multiply this whole equation 1, multiply this whole equation 1 by r. So you'll get a rsn is equal to a. When a gets multiplied with r, you'll get ar. When ar gets multiplied with r, you will get ar square. So as you can see, you are getting the next term. So ar square gets multiplied with r, you will get ar cube. And when this gets multiplied with r, you will get arn minus 1. When this gets multiplied with r, you will get arn, right? So you got all the terms except a, right? You got all the terms except a, and this is the extra term. So what we are going to do, we are going to subtract 1, subtract 2 from 1. Okay, so we are subtracting 2 from 1. So if you subtract, if you put the minus, and because when we subtract this, everything gets negative, so they gets, each and everything gets cancelled out. This might be, there might be arn minus 2 here, right? It will be arn minus 2 here. It gets cancelled out, this gets cancelled out. So everything gets cancelled out except a and this extra term. So a minus arn, right? So we can take Sn common, so you'll get 1 minus r, and here a common, 1 minus r to the power n. So Sn is equal to a 1 minus r to the power n over 1 minus r. So this is the formula for sum of n terms of geometric series. Sum of n terms of geometric series. Okay, it's a very simple formula. You can write this formula like this as well: a r to the power n minus 1 over r minus 1. Okay, see, r cannot be equal to 1, right? R cannot be equal to 1, then it will not be geometric series, and here the sum will not be defined. So common ratio cannot be equal to 1. That's what we need to keep in mind. It can be less than 1 or it can be more than 1. So we can do one question on okay, I forgot to tell you that why it is called geometric sequence. Okay, so why it is called geometric sequence? Because this is, I found it on Mathis1 website. Because it is like increasing the dimensions in geometry. Like one dimension, a line is one dimension and has a length of r. But when it is becomes two dimension, it becomes r square. In two dimension, a square has an area of r square. In three dimension, a cube has a volume of r cube. So it is increasing by r, right? So etc. We can have 4 and more dimensions in mathematics, like that. So that's why, because geometrical shapes are there, that's what is geometric progression or geometric uh, series. Okay, so let's quickly jump into sum of infinite series as well. So sum of infinite series means it goes on and on, like uh, here sum of infinite series. So I'll write two examples here. So let's say 2 plus 4 plus 8 plus 16 plus 32. It goes on and on. It, it never stops. So this is called infinite series. There can be another series 1 over 2 plus 1 over 4 plus 1 over 8 plus 1 over 16 plus 1 over 32. Right? So these both are geometric series because the ratio of any two conjugate term, like here the ratio, if you find the ratio here is 2. 4 divided by 2 is 2, 8 divided by 4 is 2. Here, if you find out the ratio, so it is 1 over 4 divided by 1 over 2, will give you 1 over 2. Here the ratio is 1 over 2, right? So here the common ratio 2, and here the common ratio is 1 over 2. Now, it's very important thing here, which will be determined by the common ratio, is converging and diverging geometric series, right? Converging and diverging geometric series. Okay, converging and diverging geometric series. So here, as you can see, this 2 plus 4 plus 8, it keeps on increasing, right? It keeps on increasing, and here the common ratio is 2. It's more than 1. See, either the common ratio is more than 1 or less than 1. It cannot be 1, right? So when the common ratio is more than 1, in like this kind of, so this is diverging geometric series. Diverging. There are different tests of divergence that we will discuss it later, but you can easily find out whether the geometric series is converging or diverging using the common ratio. If the common ratio is more than 1, then it is diverging. If the common ratio is less than 1, it means the mod r value is less than 1, or the common ratio lies between -1 to 1, then it is converging. Geometric series. In all other case except this, if mod r the means the if the common ratio is not lying between -1 to 1, in all other cases, it will be diverging. Only in this case, because common ratio can be negative also, right? So if the common ratio is between -1 to 1, then it is converging. If it is more than 1 or less than -1, then it will be diverging. Okay, so this is very important thing. Why we can say it is diverging? Because as you can see, the 1 over 16 is lesser than 1 over 8 and 1 over 32. Similarly, 1 over 64. It keeps on decreasing, and it seems like it will become 0 at infinity, right? It keeps on decreasing and decreasing and becomes 0 at infinity. So here we can find out the sum. When diverging geometric series are there, sum is not defined. So sum can only be defined if it is converging. It means sum of infinity exists, and sum of infinity exists means we can find out the sum, and that sum formula, uh, we can derive it. It's very simple to derive. We will use the same methodology. Like let's say sum to infinity is like s infinity a plus, it means we are adding to infinite, a plus ar square, like that, right? And again, if you multiply with r, so you will get ar plus, if you multiply a with r, you will get ar. If this gets multiplied with r, you will get ar square, like that. Keeps on going because it's going till infinity, and if you subtract again, so you will get these term gets cancelled out, so you will get s infinity minus r s infinity is equal to a, only a's will be left, so s infinity will be 1 minus r is equal to a, or you will get s infinity sum of infinite geometric series is 1 a over 1 minus r, right? It's very simple. And from here also you can find out, you can derive the formula of sum to infinity. If n is infinite and r value is less than, this will give you more clarity. See, if n is infinite and r value, uh, yeah, let's see here, it will give you more clarity here. See, r is this is r less than 1, and see, this formula we use when r is less than 1. Okay, so see here, we are trying to find out s infinity, so n is infinite. If n is infinity and r value is lesser than 1, then this whole thing will become 0, right? If r is lesser than 1 and n is tending to infinity, right, then r to the power n will tend to 0. So if this becomes 0, then s infinity will be a 1 minus 0 over 1 minus r, which will give you a over 1 minus r. That's what we have derived, right? So sum of infinite geometric series is a over, that's the first term, divided by 1 minus r. Okay, and sum only exists for convergent geometric series. It does not exist for diverging. Diverging, you cannot find the sum, right? And condition of convergence, like how we'll figure it out that it is a convergent geometric series or diverging. We'll find out the value of r, and if r, that's common ratio, it lies between -1 to 1, then it's converging. If it is not lying in this range, that's between -1 to 1, then it will be diverging. And if it is converging, then this is the formula to find out the sum, that is a divided by 1 minus r. Okay, let's solve a problem on this. Okay, we'll solve one question. Okay, here is the question. The second term of a geometric sequence is 12. Okay, second term is 12 and the sum to infinity is 64. Find the first three terms of the sequence. Second term, if we want to write in terms of a and ar, so u2, I'm solving here, u2 is ar and ar is equal to 12, and sum to infinity is 64, right? So that means a over 1 minus r, that sum to infinity is 64. So we'll use these two and we'll try to find out the value of we'll try to find out the first three terms. Now important thing to notice here is there are two unknowns, a and r, right? There are two unknowns, a and r. So we'll use these two unknowns, we'll use these two, only we need these two unknowns and we can find out the first three terms easily. So there are two unknowns and two equations, very simple, we can easily solve it. So here you can write 64 into 1 minus r, that is the value of a, right? So if ar is this and a is this, so let's substitute a over here, right? So you will get 64 1 minus r times r equals to 12. Very simple, right? So let's simplify. So here we'll get 64. Let's see if we can cancel out something and simplify. Let's cancel out by 3. So 4 multiplied 3 is 12 and 4 ones are 4, 4 16. So it's 16 r 1 minus r is equal to 3. Now it will, you can see that it's forming a quadratic. 16r minus 16r square equals to 3. Now take everything that side. So you get 16r square minus 16r plus 3 equals to 0. Now you can use the calculator to find out the value of r, or you can use this r is equal to uh, quadratic formula you can apply, right? So 16 plus minus square root of minus 16 square, uh, I think we can use it without, we can or you can, let's I'll show you. 16 plus minus square root of minus 16 square minus 4 into 16 into 3 divided by 2 into 16. So you can solve this, you can get the answer of r, or you can simply use factorization method here. So 16r square, see 16 into 3, 16 into 3 is 48, and we can make factors. Okay, I'm going to use splitting of my delta. So I think 12 and 4. So negative 12 and negative 4 are the two we got. So two factors, minus 12r, so minus 4r plus 3 equals to 0. So here we can take 4r common. So 4r minus 3 minus 1 common. So 4r minus 3 equals to 0. 4r minus 3 and 4r minus 1 equals to 0. 4r minus 3 equals to 0, or 4r minus 1 equals to 0. So here you will get r equals to 3 over 4, and here you will get r equals to 1 over 4. Both r are acceptable because both are lying between this range minus 1 to 1, right? So both are the answer. Okay, we need to find the first three terms. Okay, so if r is 3 over 4, if r is 3 over 4, what will be a? So we know AR is 12, right? So AR is 12. So A will be 12 divided by R, and 12 divided by 3, and here 4. I'm dividing 3 over 4. Okay, so 4 will go up. 3 4s are 12, and 4 4 16. So we'll get A as 16. So once you got A, that's the first term. So u1 is 16, u2 we already know it is 12. So u3, which is ar square, so a is 16 times r is 3 over 4 square, right? 16 times 9 over 16. So we got 9. So the first three terms is 16, 12, and 9. And similarly, you can find out with r equals to 1 over 4. So when you substitute r equals to 1 over 4, so when you substitute r equals to 1 over 4, so what will be the value of a? You will get different value of a, right? For r equals to 1 over 4. I'll show you how to find out a. So a is 12 divided by 1 over 4. So 12 multiplied 4, 48. Right, so that's a, that's the first term, this is the second term, and we can find out the third term by using ar square, same way, so that you can do it.